We rarely stop to think about the fuel that powered you here today.
Not at all.
Where did that gasoline actually come from? The gas lighting your stove? Could it, originate thousands of kilometers away in a Russian reservoir? Or maybe a well in the UAE?
And that journey, which we are about to deep dive into, is arguably the most complex logistical feat on Earth.
It has to be.
It's a vast global network that powers everything. Transport, electricity, industry. I mean, to make sense of it, you need to understand the engineering, the discovery, the finance, and all the regulation behind it.
Exactly. So to make that complexity a bit more manageable for you, the entire industry is segmented. It's basically three key phases we're exploring today. Upstream, which is where we find it.
Midstream, where we move it.
And finally, downstream, where we transform it into something useful.
That's the one.
Okay, let's unpack this. Before we even think about drilling, how is oil actually made? We all hear fossil fuel, but what did that incredible geological process actually look like?
It's just an immense timeline. We're talking millions of years. It starts small, with tiny marine organisms sinking to the ocean floor. Then they get covered by sediment, and the high heat and, enormous pressure slowly cooks that organic matter.
So it's literally being cooked.
Yes, and it transforms first into a waxy substance we call kerogen.
Kerogen, okay.
And here's where it gets really interesting. Oil only forms in a specific temperature range. We call it the oil window.
The oil window.
Generally between about 60 and 150 degrees Celsius. If it gets too hot, you get gas or even graphite.
Wow.
Once it forms, that liquid hydrocarbon, it migrates through porous rock until it's finally trapped beneath an impermeable layer, a cap rock.
And that's the reservoir.
That is the field we eventually drill into.
So the complexity of the upstream sector isn't just about digging a deep hole. It's about spending billions on seismic surveys and exploratory drilling just to find that ancient, perfectly baked geological trap. It's high risk, high reward.
Precisely. And once the crude is out, the real logistical nightmare begins. That's the midstream segment.
Getting it from A to B.
Yep. And for moving it overland, pipelines are the undisputed champion. They require massive initial capital, but over decades, they offer the safest and most cost-effective transport.
But not everything goes through a pipe, right? We see those massive supertankers crossing oceans every day.
Absolutely. Global shipping is essential, especially for intercontinental transfers. And if you compare that to, say, road transport, you see the trade-offs right away.
You mean tanker trucks?
Tanker trucks. They're necessary for some routes, but a long haul, like Mumbai to Delhi. That can still take 1 to 2 weeks. It's slow and expensive compared to bulk.
So we've got the crude to the refinery. Now let's talk alchemy. That heavy black muck isn't useful until it hits the downstream transformation. What does refining actually do?
Refining is basically separation and transformation. The key step is fractional distillation. You can think of it like boiling a complex pot of oil.
Okay, so different things boil off at different times.
Exactly. Different components boil at different temperatures. So the lighter fractions, like gasoline and jet fuel, they rise to the top and are collected first.
I see. Then refiners use processes like cracking to break down heavier molecules into more useful products like gasoline. And that's how 1 barrel of crude becomes diesel, jet fuel, and crucially, the petrochemical feedstocks for almost every plastic you use.
So what does this all mean when we look at global consumption? Who's driving this massive, complex, global output?
Well, the transportation sector is the colossal consumer. It accounts for over half of all global oil demand.
Over half, just for moving things around.
Cars, trucks, ships, planes, they dominate. And the demand drivers, they're concentrated. The United States, China, India, and Europe. They're the biggest consumers by far.
It just requires a staggering amount of investment to maintain that flow. It sounds like the key to the future is getting smarter, not just drilling harder.
That's spot on. And what's fascinating is the digital revolution happening. AI and machine learning are now used heavily in upstream to process seismic data, helping locate those traps faster.
And what about in the midstream? In midstream, you have predictive maintenance guided by ML monitoring pipelines to prevent costly, dangerous downtime. The demand is so great that the global AI in oil and gas market is projected to reach over $25 billion by 2034.
That incredible journey from tiny ancient plankton to a global system optimized by cutting-edge machine learning is just a spectacular blend of deep geology and complex engineering. We hope you now see every drop of fuel through a new, informed lens.
And if we connect this to the bigger picture, knowing that the Middle East holds the largest share of reserves and 4 major economies drive most of the demand, what new friction points might emerge as the world moves towards smarter energy systems. That's something for you to mull over the next time you glance at the petrol pump price.
Mutual fund investments are subject to market risks. Read all scheme-related documents carefully.